Hey, welcome. It's our second video, and what we're going to do is look at a couple more features and then just run through these interfaces and take a look at them. First video, we explored this one pretty heavily. Let's go ahead and look at analog controls. Okay. And this one, it has a child interface to it. Okay. With a lot of various features on it. If I want to, and these just access the control instructions from MakerPlot. For example, for this button here, let's go ahead and take a look at some code behind one of these buttons. So I'm going to hit F3 here. And down here is the event code. When I click this button, it just does a object plot reset. Okay. Or to reset scales, okay, if I move this one, get focused, plot reset scales. So that's just a little bit of code that runs when we press that button. Okay, with the child interface here, okay, each interface, once the child is created, we can go down, we can open up from here, controls, and reopen that interface. Or there might be a button on it on the screen, for example, such as open controls. Okay, so it reopens that control interface. Also, we can hotkey it. If this is closed down, I'm on the plot here. If I do control 1, it's the first child. I have more children interfaces, be control 2, control 3, control 4, and so on. Or control 0 brings us back to the main plot. Okay, some other menu items up here. We looked at file pretty much. I didn't finish this last time, but let's run down through it. Let's run macro. Macros are small scripts of MakerPlot instructions that can be run to do various things. And if they're in the macros folder, we can access them here. For example, let's add to this. It's going to run a script that adds this to the current plot. Is this for the current plot? So let's go ahead and do 4 channel lines. Okay, there's some parameters that we can change on it, the interface name and the interface title for it. And we say, okay, and it opens up a new child window here for plotting that. And this interface will tell it to keep on top, so it's always there. Let's go ahead and connect, do some plotting. And just visualize our data in a different way. So it's using those incoming values and using drawing functions to draw that data in a different, interesting way, which may be meaningful for the data that you're bringing in. And right now, I can't say it's terribly meaningful, besides it's kind of cool to look at, interesting. Okay. So those are macros, and those are explained the reference files, what they're all about. If we're in edit mode, we can start doing things with this plot. Let me stop plotting here for a second. If we go to edit mode, which is F9, we can also hit F9 to go into it. But we can start adding things to this plot or taking things and moving them around, positioning things if we want to, or adding new controls to it. Hitting F2, we can bring up the controls palette where we can add buttons and toggle buttons and more plots and various things, function blocker, timer, data logger, the image buttons, a lot of different image buttons we can add to the plot and such, virtual switches and toggle switches and slide switches, icons. If you like icons, we can add a bunch of icons to this to do various things for us. Indicators, here's our meters down here, and various gauges and displays and such, and LEDs to indicate information. Just to demonstrate one here, let's again, I'll just toss one on just to demonstrate real quick here. So let's take let's see, what do I want here? I will just put a meter on here somewhere. Let's take this plot here for a second. Let's bring that back some. Go back to F2. Let's see, do I want a meter? Oh, let's try thermometers. thermometer's code is kind of complex. I already showed how to set the values on that. I'm trying to think of something more interesting here. Well, let's go ahead and just put an LED on here. Okay, it pops up and asks for the name of it. It's called LED, basic name. Okay, we do like LED heater or something. Text for the LED, if you want some text for it. I'll just say on for it. And then we go over here and we draw it on the screen. And there's our LED. And right now what's assigned to for its update value, that's the value it's going to use to update that control. So it's using DN0. Well, DN0 is digital N0. So it's going to use a digital bit 0 and update that LED on or off, okay, based upon the stats of that bit. Or for an analog control, it would be like AN0 or AN1, or we can do math down there for various things. Okay, let's do F9, pop out of edit mode. So we're back in run mode. And let's reconnect. Okay. And as digital data comes in, as it should be changing. 0, we're set. DN2 once. Give it a second here. There he goes. Okay, so my data was just changing very slowly. Okay, so it is blinking, changing, and when we look at analog, we look at digital plot, we'll see that digital data coming in. Oh, we've got to reset our axis here. I'll replace for some reason. That's bad. Okay. So this plot here, getting back to talking about the plot. Again, we can open a control window. This one, if we have an error down here, we can see error down. Okay, the processing queue exceeds 100. I'll look at some things on here I didn't point out in the first video. But on the serial controller, there's 2 lines. The first one is the amount of serial data coming in and how full the serial buffer is. If it gets full, it'll empty out and give you a warning and start filling again. Okay, so the bottom one is how many instructions in the queue are waiting to be processed. And instructions are like for clicking a button and putting that instruction to reset the plot or whatever it's going to be. But if it gets backed up in processing instructions, for example, or updating various things, you might see those changing a little bit. Again, they start filling up. That means that serial data is probably coming in too quickly. You need to slow it down. So various features on this plot. Again, we have log data. Okay, open log. Okay, log control. Their min max average. We just have those on there again. What channel they're looking at again. And take snapshot, open snapshot. So basic features on this one. So let's go ahead and disconnect. We'll go back to the, normally it's a nice big plot for doing various things. Again, looking at that control 0 for that, control 1 for this. Again, a lot of this is just accessible through pop-up menu, but it's just an easy way of turning things on or off. Again, if we look at the code for it, if we want to turn on log scale instead, we can log things in log scale or plot XY instead, as it's taking sets of coordinates and plotting an XY pattern instead. But if we look at the code for this one, look at what happens when we click those. Okay, it's just running some code here to turn on the plots. Plot XY lines equal to 1. If I turn that button on, or if I turn it off, plot XY lines equal to 0. So you're welcome to poke around and see what the code is behind all these different buttons. If I'm plotting real time showing down here, hours, minutes, seconds, or just seconds. Auto scaling features are here. So if you don't want to clutter the screen, you want something over here instead to do some of those things. I could increase this to put the pauses in there and get things like that. Okay, here's our data points down here. And if we do a manual refresh time. Sometimes all that plotting tends to slow things down, so we can do manual refresh where it refreshes every second, for example, instead. And so there's some nice features on that child interface. Let's go back to open selection interface. Let's look at the next one. Okay, so analog and digital. So let's plot some analog and digital data and meter it and show it in various ways. Okay, my servo controls down here on this one. So let's go ahead and connect. Some data coming in. Okay, so this is bit 0. And previously, when I was doing DN0 is actually the first bit that comes in. And then they're assigned to LSB to MSB on here. So DN0 does not correlate to bit 0 because as we look at different binary numbers, as we have more leading zeros and more leading digits, the last value is always bit 0. But the first value that comes in is called DN0. So that's the one that comes in. So the slight differences here with that. Again, looking at these, okay, those are all blinking in response to the digital values that are coming in. Again, we can do various things. Now the digital plot I need to make as versatile as the analog plot and add some more features to it, which I haven't done yet. Up here, we just have a couple gauges as bar graphs. Okay, we can set the min and max on these for how much we want those to span. So we can set the min max values on those. A mark feature here, if I want to mark the plot somewhere, put mark there or something else, I can double click and annotate my plot a little bit. Okay, so it has it on there. Reset both. Oh, synchronize digital x-axis to analog plot. Okay, so we can synchronize those two axes together. Double that a little bit. So we can keep those two plots kind of synchronized together, which may be a nice feature for trying to correlate the two. Okay, reset both plots, bring it back to time 0. Again, this just runs a code to reset both. Okay, so some nice features on this plot. Go back to our selection interface. The next one briefly. So we did that one. This is just 4 meters, 4 plots, I mean. Okay, so as we connect, we're just using the same data over and over again. It's just coming in and doing it different ways. Okay, and so if we look at this one, how this is configured, we're only getting one channel here, one channel 0, channel 1, channel 2, and channel 3. If I go to settings on this one, okay, under plot channels, I'm telling on channel 0, just a plot channel or AN0, and all the rest are turned off. I don't want to see the other channels. Okay, so I just turn those off. Okay, and this would be channel 1 or AN1, AN2, then AN3. And again, this has a synchronized feature to it to keep all those synchronized. So if I take this one and scroll around a little bit, keep all those synchronized together if that's what we desire, or we can turn that off. And all I'm doing there is using a change event. If the X value changes, then it triggers all the other ones to change as well. Other feature, we've got snapshot feature on this one, reset all plots, reset min max average. Okay. Sync timing, how often do we want to try to sync up there? Okay, we can see a little stuttering going on. Now let's try decreasing this a little bit, make it 10 instead. Yeah, it should be a little bit smoother. Okay, a little glitch there. And trying to refresh that often, I didn't care for it a whole lot. So can't do things too quickly sometimes. Okay, that keeps it a lot smoother. So don't want to refresh too often because we have large amounts of data. This one's just a bar graph. Again, that's just the settings we can go to. Oops, excuse me. Plot style. Right now it's set up as a bar plot. We can change it into a regular plot. Oops, bar plot. That's what I want. Okay, so we can change what style that is or turn that off. All right. In bar plot, up to 10 different values can be plotted here. If we have 10 different values coming in, each one will be plotted. And what it shows is it shows the maximum value reached, the minimum value reached, and the average value reached for each channel. So if I reset min, max, average, okay, these are all auto adjust again on me because auto Y is on those. But we can see those min max lines being pushed up and down to indicate those min max values. Okay. Okay, so let's go back and check the next one. This is an interesting one. Okay, so it has a child window here. And what it is, we'll get some stuff plotting here. And go back to our window. One for that window. Okay, or open formulas we could use. But we can, for each channel, define the formula from here, what it's going to use. Okay, so these channels are off. If I want to turn that channel on, I can start looking at AN2, analog channel, analog input 2. Right? It also has some fairly sophisticated features to it, such as if I wanted to do on this one, if I want to look at the average of channel 0, and here's a code for how to get the average of channel 0. Select that one. Now this will show me the average of channel 0. Let's go ahead and let's reset min max average. And we can see the average line now, is a lot more responsive as we try to find that average to be around 0 over time. Or perhaps we want to look at the standard deviation of the last 250, okay, the last 250 samples. And again, this is the math code to call up and take plot the comma separated values for channel 0, take like to the last 250, and get the CSV value of them and perform a standard deviation on those values. And so it jumped up pretty high to show the standard deviation of channel 0. So that's just, one feature. You could type your own in there and add to it if you want, add other formulas and such, or information to plot. So otherwise, log channels and enable logging on that. 25. Okay, that's a skip value of how many we want to skip. And that's important for like standard deviation. If we start skipping values, then we won't have a true standard deviation. So we want to set that to 0. But in this case, since it's changing so frequently, nothing's ever the same twice. So it's not really skipping any channels. And of course, we can scroll up and down if I haven't shown that before to the min and max of the analog. Again, if one channel is really out there, you might want to turn that channel off just so you can scroll within that range of what's being plotted instead of some erroneous or some channel that's way up here, excuse me, at 2000 or so. And you can work through the various menus and such. Different folders open the snapshots or logs that we looked at, or open the application folder itself, the root folder of MakerPlot. Where the help is important, the references. Okay, there's a pretty extensive reference in here. This looks like an older reference. I haven't updated this version yet, but there's a getting started here, which is really important too. A very simple, quick start to go through the very basics of plotting and such in the newer help files. Okay, so let's go ahead. Let's do file. Let's go back to selection interface. The next one. Okay, this one's interactive analog digital. Pop that one open. Let's go to our microcode because we need different code for this one. This one's the interactive example. Let's go Arduino code, interactive analog digital. Pop that one open, upload it. And we'll look at the code briefly. Okay, so a lot of things in here. It does control eventually the LED on the board. I just have a basic board set up here, and then look at the baud rate. Okay, the baud rate's pretty high on this. We'll get some fast action out of it. And this is the code to read. The code's a lot more sophisticated than it has to be if we're just going to read a single control. But with this code, what we're doing is reading a bunch of information at once. Instead of doing an individual read and update and read and update, it's being read. So there's an instruction to read something on MakerPlot. Read slider channel 0, slider channel 1, slider channel 2, 3, rocker bit 0, rocker bit, and so on. So it reads them all at once. And then we save that data. The help file shows an easier way to do this for just single controls, but you can take this and modify it. But read serial read string until it reaches the end of line. And then it prints does a serial print line to do this again. So it does it twice, and then it reads it in. And then what it checks is to make sure both those reads were the same. That's for error check. Make sure two reads are exactly the same. Otherwise, don't use that data. So if they are equal to each other, it goes down and parses through all that data, stores it from that commented limited string that comes back. So it just comes back as, 5, 10, 15, 20, 1, 0, 1, 0, for example, all separated by commas. So it's going to read and fill in that read string the values of each of those controls. Okay, and then we go through, we parse it all out. And then once we parse it out, or if there's an error, it's going to blink the label status on the screen. It'll do a label status. Okay, do instruction here for label status. Back colors can go red, and it's going to print the line. Read error detected, maybe do changing data value. So print that out so we can see that information in the debug window. Delay 20, and then it'll update the time, system time milliseconds, and show that in status window so we can see what the system time, or it'll show the system time milliseconds in the label status. So we'll take a look at that. And then we just go back and we send all that data back out again. Okay, so channel 0, comma, channel 1, comma, channel 2, comma, channel 3, and so on and so forth. And then for digital, okay, percent for digital, bit 1, or bit 3, bit 2, and bit 1, again, to get them in the LSB to MSB order, and then print bit 0. Again, this last one ends in a print line, so we'll do the carriage return at the end of the line. I think I had do I have the LED coming on? I thought there was code turn the LED, the board's LED on if we reach a certain value, but I don't see it in here. I guess it isn't, but you can add that. If channel 0 is greater than whatever, then, or if a bit is equal to 1, then turn on that LED. So it'll be pretty easy to add that code in here to control the LED from the interface. Okay, enough talking. Let's go ahead and upload this one. Oh, didn't select board yet. Okay, upload it. Then uploading. Okay. So getting back to this. Okay, we'll look at our serial control. And it's set up for 115200. okay, which is the baud rate of the Arduino, to make sure baud rates match, or we'll get garbage like we saw earlier in the last video. In the serial monitor for Arduino. On here as well, again, here's our status box. It's going to blink red sometimes on us because we have code coming from Arduino to make that blink red. Okay, so let's go ahead and connect and see what all happens here. Okay, so we're just plotting those basic values out here. Again, if I take a slider and I adjust the slider up here, we can see the data from the Arduino is changing. So I'm able to get data back to the Arduino to spit out that value to update that plot. Or channel 2 and so on and so forth, or channel 1, this would be channel 2 and channel 3. Okay. We also have a little indicator here. It's one of the controls that will change based upon this data here. Change its rotation. And just a little visual addition to this. Okay. Show history, how much history of old lines we want to see as it redraws a new. That just changes the color of it as we adjust that. Okay, then we have our switches are for our digital data. So as I change bits here, again, the controller reads that and updates what it's saying for digital data. Or these switches could control some device, lights and pumps and various things on your process, be able to read pressure and be able to control those. Okay, so we can update all those. Okay, turn those all on. Again, we're updating the bits here based upon that incoming data, so we can see it change or turn it all off. Okay, and we can see that blink for a second, because for a fraction of a second, if I did 2 consecutive reads, they weren't identical. So we get a little blink here just to say, well, there's a little bit off. If I open up the debug window, F4 to open up the debug CLI, I can see, the number of errors I've gotten from when the data wasn't exactly the same. Again, we read that, so a mismatch in those 2 reads, and blink that label box, and did a print statement, a question mark, print to the debug screen so we can see that information. And so other than that, it's pretty much, yeah, that's what it is. Again, we can take that and start controlling real devices and reading real things or controlling real things. Change that temperature set point or change that pressure or change whatever we want to be able to control our system. It's more like an HMI used in industrial environments where we're using an interface to control some processes going on. So you can test that out, play with it. Let's go back. Now I've got to go back to the other Arduino code before I do this one. There we go. A little sluggish here. And the thing is with MakerPlot and Java in general, when I delete things like all those controls, they don't really disappear out of memory. They're just marked as no longer in use. And so the more I close and reopen things, change back and forth, the more garbage I'm getting accumulated in my operating environment right now. This one I want to open up, but it's just, well, what the heck, huh? There's alarming going on. Okay. Okay, so turn off alarms on all these, but they're all sitting at 0, which was an alarming condition. All right. I have to go back to see if I can find my other Arduino code here. Oh, so much. Probably that one there, sine, cosine, digital. There we go. I'll re-upload this one quickly, just so I get back to my data. Okay, so let's go ahead and connect. And so again, we're bringing in 4 channels of data, and we're just updating meters with them. Again, we can turn the alarms on, so they all alarm. There's a few different ways. We can double click a meter to turn those alarms on, or we use a menu to turn those alarms on. For example, this button here, for example, if I look at it, F2, sorry, F3, okay, the code it runs, all meters, okay, meter wildcard, alarm on is equal to 0. So basically turn all the meter alarms off. There get some icons down here to log, okay, and delete the logs, or to log data and delete them, I guess. Let's see, log alarms, log data, write the log file. It uses some icons on this one. Open up those data or delete that data. Okay. Take snapshots or open up the snapshots folder. Again, you can look at the code behind all those. Icons are nice. I haven't used enough of them. Okay, and then individually can turn logging on or whatnot. Sound the alarms. Log on alarm. A while ago, can't remember what that does. Okay. Okay. Let's go back to our selection interface here. And the last one here is just for fun. A little sci-fi. I actually put the servo control on a child interface so it doesn't interfere with the look here. Okay, 9600, COM7, connect. So on this one, we're just using those 4 channels to control the position of these various objects. Try to hit one here. Hit a 3 on it. There it is. Okay, so it's an image toggle button is what it is, called arrow 0. And the code for it, its update value is we're just taking that incoming data, spanning it a little bit, and controlling the position based upon the incoming data. So you'd have to, right now it goes from 8 to 72. So the incoming data is going to be spanned across that range of values based upon the text min and text max of, let's see, control 0, control 1. So we can change here the range of data we're getting in to control what ranges will be controlled over for 0 to 100%. And then down here, we're just doing lines again, taking all the data and doing some ovals with it to, again, visualize that data. So this always kind of reminds me of Star Trek. And I thought that the med beds were cool in Star Trek, with little things above the head going up and down to indicate the various parameters. And down here we have a toggle on or toggle off, so we can turn on or off the serial control. Again, the code for this: serial port open or serial close port, open port or close port, whether that toggle is on or off. So there's a lot we can do. Okay. File, open the selection interface, go back to this one. And I think that about covers it for this presentation. Thank you. I hope you got something out of it, and happy plotting.